I would like to welcome Martin Frey, and you are head of freeform division at Blumer Lehmann, and you will talk about a very spectacular project in Stockholm, the Stockholm Wisdom. But you will also tell us more about Blumer Lehmann and about your work. So very welcome to this stage. And I think you have the pointer here and everything should be set.
Perfect. Thank you very much for this friendly introduction. Thank you as well to the former speakers. We understood absolutely nothing. Sorry for not presenting in Swedish, but basically we felt like it's absolutely the same topics you discuss here as we did, as we do every time, every day, and as well as we are working around the world. In a lot of countries we have those kind of topics, and we feel often, a bit kind of, it's for us also a task to show what happened and what could be the future, the future of timber. We are actually growing as well into the height, and I always say when the discussion starts about costs and fire in the timber business, I always say it costs around the same price, but it's at least 2 times better regarding fire and regarding naturality and regarding a good feeling to live inside of it. That's just what I want to say too. Yeah. So I want to introduce the project of Wisdom in Stockholm, as you already mentioned, Thomas, and thank you for this introduction. This project might be something totally different to other timber buildings, and I want to show you a bit. I want to start quickly with an introduction of the company and go after very close into this project details to show you a bit what challenges we have to work with. So this is our company plant. It's basically the plant and 147 years of experience of timber, and we try to push the limits here, and it has started with a sawmill basically and a small carpentry, and it was grown over the years to a timber construction company which was grown quite fast, and an elemental fabrication, a planning factory, and here on the left side the rest material part with an own power plant where we produce electric energy. So we try to close the circle of using 100% of the delivered logs, which is a main task for us. We do products like claddings here in the sawmill, battens, and also lamellas for glulam. We do the housing part, the building part. And as well, we do the salt storage silos for the road maintenance during the winter time. And out of the rest materials, we are going to, or we always try to use it as a pet kind of pet beddings, and doing pellets out of it for heating system, and also briquettes out of the bark. What then is remaining, so such as wood chips and stuff like that, is burned off in the power plant, where we produce around the half of the energy we use for the process. We are based in Switzerland, in the eastern part. We have some different subsidiaries in the western part of Switzerland, in Luxembourg, Germany, another one in Sydney, which is currently quiet, but we have another production in the middle of Germany. That's an overview of our current plant under construction. To show you the construction site, we are actually going to build some new factory halls in this area, and as well a new headquarter, which I'm really looking forward, because we are grown over the years, and everywhere is some office space, a bit exposed to everywhere, and it's not the really nice collaboration but this is something what really would go forward and be better in the future. That's Katrina. She's leading the company in the 5th generation, and she's always kind of pushing the limits. And believe me, if we have an idea to do something out of timber, she rarely says, "Don't try this out." She's always kind of looking out for also in the future, not only 150 years back. It's more as well the future, which is our main task, and to do something new out of that. So we are in the timber construction part. We are actually 3 business or 3 departments. One of them is the timber excellence. We call it excellence because it's very diverse. It goes to multi-level stories. It goes to hotellery and so on. I will show some examples afterwards. Then it's the free-form business in the middle, which is my task. That's the business where we go most time abroad. And it's also, we cannot decide in which country or in which land we want to build it. The projects are there where the client is. And to the right side, the modular building part, which is one of the biggest one as well in our company, where we build lots of different projects out of in the modular way and the very high prefabrication. That's us 3 on the left side, Markus Rutz, which is leading the excellence part, myself in the middle, the freeform, and to the right side, Lukas Osterwalder, who is leading the modular part. In the background, some of you maybe know Richard Jussel, our former CEO, who has a lot of experience and is basically our timber dictionary or Wikipedia, we always say. Just to show some examples, the housing for sure is a big part of the company, and as well gastronomy and tourism. This one, for example, is a mountaintop resort in a ski resort. Office buildings like the one in Zurich from Shigeru-ban. Some industrial buildings with office space on top. Extensions on existing building, which is a very important and a good topic for timber construction because of the light structure. And then the modular buildings for sure, which we most time use for education and office space, sometimes for hotels as well, but also lots of temporary buildings which can be replaced, such as small space or artistic space. Then the most sophisticated part of the company, for sure, the freeform structures, which is also, by the way, the most risky part of the company and cannot be the biggest one. Some examples like the casino in Venlo or the Cambridge Mosque in UK, which designed by Mark Barfield Architects. Another one, which is a very nice one. Another project from Shigeru-ban, where we felt like in the first time, should that be real? That can be a water on top of this timber structure, and they really did a timber facade on top of it, and there is some water flowing over it, and it's unlucky that the video doesn't work because it will move and we can see the sunlight which is coming through the water and make some nice forms and movement on the timber structure. Is it maybe that we need to switch to presentation, or? Yeah, now I think it doesn't work. So we obviously are involved in all the parts of the different project phases. Often, especially for the freeform buildings, we are contacted in a very early stage to help in the initialization, to find out the right forms, to optimize also static calculations and optimize the costs of a structure like that. And often we come to the as it was as well in the Wisdom project, we come to the point where we feel like we need to do a mock-up to find out more about how we could build it. And this is the point as well where we jump in and do a lot of calculations or pre-analysis together with our partners such as SJB and Design to Production. They were also involved in the Wisdom, and it's quite crucial to figure out then what happens with this type of geometry and what that means in terms of static load-bearing structures. How we normally build a free-form structure is quite different to the Wisdom, because we normally generate the blanks and the forms to get the raw pieces and organize them quite well in a certain form that we can assemble it at the end. So the idea is starting from the assembling process, or let's say from the assembling process back to the planning. And then we mill it to the final shape and sending it to the building site and install it. So this one is the machine where we produce everything on this 5-axis CNC machine. Workpieces can be up to 27 meters long, and the machine capacity in terms of cross section could be 5.4 meters wide and 1.35 meters high to get this curved shapes milled. That's how it looks sometimes when it comes out as the machine. This, for example, is a piece of timber for the Swatch headquarter, and we do also the after the machining let's say the treatment for it's most time it's a UV treatment to let the timber staying lighter for a long time. Then we do also the pre-assembling, like such as some connectors or glued in steel rods or stuff like that. And then we put it into a foil and do the logistics. And the foiling is quite an important thing, because we work in an accuracy of about 0.5 millimeter or even lower. And the moisture impact of a transport phase would be a critical point to be ready to be sure that it works with the installation as well. This, for example, a picture from the installation of the Swatch headquarter here as well. It's basically the biggest timber grid shell structure we have ever done, up to almost 210 meters long. Quite a bit the span, but it's also supported in between from the main structure below. Some of you have maybe seen already the building. It's quite a nice cozy or kind of cozy feeling inside, and as well maybe the outer side. I don't like pretty much the outside, but the inner side I really like. You can imagine. But let's talk about the Wisdom. It's on one hand, it's the dome inside of this grid shell structure, which is also a really nice project, but it took not that much effort in our company as the grid shell structure has done. But I quickly want to show you just how it was assembled. And at this point, I really want to say as well, thank you to our partners, Stora Enso. So they are kind of project partners. They are donating the material for this Wisdom, and that's the reason why we use the products from them. And they have really proper pre-milled those kind of CLT boards, and have delivered it so that we could assemble on site. But all the engineering before, and also the exchange of the data and of the milling, let's say milling boundaries and rules, and as well the organization in the right order of the pieces, that has worked out very well together with them. Some pictures from the installation. it's basically just a dome, but it's, by the way, 20.5 meters wide, so not a small one, and it will be at the end kind of a cinema inside, which is a 3D cinema, and tells a story as well, and a lot of information about the Weltall, about the, I don't remember the name. Universe, exactly. Perfect. Thank you. Yeah, that's the final shape. Looks also pretty nice. And then, but the main critical thing was the grid shell, and we felt like, oh my God, that's obviously not an easy one when we get contacted, and it's totally different, as I said. So from the curved pre-production curved beams in 2 direction or in even 3 dimension, we come to a flat panel, and we should work out a proper grid shell roof structure. How can we get to this? And then we've involved some famous person. One of them is Hermann Blumer, which was also the founder basically of our company, and is also the part of the founding team of the engineers. And he is quite a famous one in terms of find out new ways, and he's also always thinking backwards and look what they have done in the early times. And the other person is Hans-Ulrich Grubenmann, which was in the 18th century one of the most, or he was the famous timber engineer, and has done a lot of bridges over the Rhine and a lot of other rivers. And he has always worked out he hadn't the ability or the software or the whatever to calculate everything, and he has explored the limits of timber with building models and put some load on it, and to find out if it works or not. And there is a certain story about it, about him, as he has done a bridge with a center core as well, or a center basement as well, and everyone was saying you need this basement in the middle of the river, and he was always saying, I don't use that. I just can build the bridge from one point to the other. And when the bridge opening was done, he put out the middle the middle support, and just the bridge was staying for many years. And unfortunately, a lot of those bridges were burned down during the wars and so on. But the system he used there for this special girder is basically to double several lamellas together with each other, and this was the idea of the inspiration. We felt like we should have a combination for the wisdom from this old technique with the ability we have today with engineering, static handling geometries, and also milling timber pieces in a 5-axis machine. So it's basically a simple, we call it a doubled girder, but used in a curved way and produced in a very accurate 3-dimension. That was the point when we decided to make a first mock-up, and the first one was, by the way, done from the top of the grid shell roof, because we felt always like this big curvature could be one challenge, and the other curvature in the deflection would be the second challenge. So we did the first one. We found out that we can do it with this doubled girder. And we tried it first time with 39 millimeters LVL lamellas from Stora Enso. But we learned as well that the curvature is not easy reachable in this with this thick lamellas in 4 layers. But we wanted to try it out because 4 layers to mill is quite easier than 5 layers for sure, because of time as well. We did this mock-up, and we had a lot of learnings. So the workflow was basically to cut the 3-axis milling for the lamellas, for these 39 millimeters lamellas, and did also the template on a CNC, on our CNC, bending and fixing the lamellas to the template, and then found out what happens when it's milled, doubled, and removed from the jig after the milling process. Here you see some insights of this production phase. Yeah, sometimes looks a bit handcrafty, but yeah, you cannot find it out if you don't try it somehow. And we learned that this 39 millimeters lamella have pretty much spring-back forces, some more than we expected in the beginning. And that was the point, so that we found out we need to do it. It was curved for sure, but it was springing back to a bit too much to get this final shape. And that was the point where we knew, okay, we need to make 5 layers with a thinner lamella, which was then at the end as well the decision to do it like that. And it's the second mock-up we did was about this deflection, and we felt like could be a challenge to just get this deflection with just doubling it against each other with all that forces. This picture is, by the way, a typical start up of a project like that when we sit on our table and just discuss if this is possible or not. It starts sometimes with a very small mock-up to figure out how we could do the bigger ones. That was basically then the bigger one. Also tried out with 4 lamellas first because of the less bending radium, but also this one we have decided to do it afterwards in a thinner lamella. Yeah, I already mentioned some of those learnings, and that was then the final outcome of it. We decided to do it in 5 layers with 5 lamellas. So, by the way, in all, 25 layers to get this shape done. And then the dovels. This is another important topic you can imagine. We always have been discussing about the shape of those dovels to be sure that we can assemble the lamellas over it. And we also decided to start with the first layer A, to pre-glue this layer and mill it in a very accurate way to be sure that we can have a really proper start on site, and it's kind of a formwork of the main structure and can build up from this point then. And that was the moment when we had the contracting time. So we had to know about roughly what it should cost. That's also the other topic. Until then, we had no idea what it could cost because we didn't know how the process is, how many lamellas, and so on. And then it was the contracting. And also then, not before this point, it has started with all the detailing calculations about those dovels and screws and fixings. And this is always a bit the critical point. It needs also a lot of trust from client side that we are on the right way. That's not every time easy to explain this kind of process to the client. We need this mock-up, we need another mock-up to know more about that and to find out how it could work. Assembly concept as well, very important to be sure that we are able to install it at the end on site. So this is basically the way we did the first layer, which is glued. And then all the upper layers B to D, which are not glued anymore, they are just pre-milled and assembled on site to this certain shape and packed together with these dovels and screws. Then these shear dovels, which are bringing in the high loads to the columns. And the final layer E on top of it. As well, the cantilever around it to have a very nice shape around it. Yeah, and then was a moment like to get this contract done, we need to feel like a bit. We felt like a bit this one. We have never tried this before. So that we are really sure that we can do it, and it's basically a statement of a very famous Swedish lady. And that fits a bit together. And there was also the moment when we said, okay, let's go for it. And we tried out with this client. We had this groundbreaking ceremony. By the way, this evening we can have a party of the topping out ceremony. So the project is almost finished and will be done until Christmas time. Yeah, we are really happy about it. And it's yeah, I'm really looking forward to see it this afternoon or this evening. How it works out. To get this done, also this full collaboration together with client, architect and engineers, it's always kind of a loop, and a planning loop to get these really detailed topics, and as well a lot of design. For example, the canopy edge has to be horizontal and has to be straight in the footprint as well. So you have to get the real proper roof shape to be sure that this edge is perfect and so on. So all that stuff we tried also out after contracting. We did a third mock-up. So sometimes it's weird, but with this third mock-up we learned really a lot about how this works, and as well how to assemble. And the guy who is responsible for the installation now was installing the mock-up in our factory, and I hope that video works. It doesn't, obviously. Yeah, it's a time-lapse video, which obviously not works, but yeah, it's a bit sad. But here you could really proper see how we have assembled it together. Ah, yes, now maybe. It doesn't start. Okay, I will go ahead. Yeah, we see some pictures in the end of the presentation. So the collaboration through this 3D model, and it has nothing to do with BIM. It's just a structural exchange of a model between architecture, structural analysis, and production possibility and assembly. So this is kind of a circle which turns several times to find out how we could work this out. Then you have the parametric model with this master surfaces, bring the grid shell or the grid on it, define all the details, and then it comes to a deeper analysis and a lot of exchange always through this 3D model. So it's every time a turn around this model, and it has also a lot to do with communication between client, architect, engineers to be sure that everyone gets what happens in this phase. And as you can, this for example is very interesting. As you can see, an easy grid shell would be if it's round, like the dome, or if it's mirrored, it's also easy. But if it comes to a shape like that, which makes has got a flatter side, then you have the structural challenge to solve there. It's everything designed by Rhino software, which may a lot of you also know. A lot of Grasshopper tooling in it, also the detailing of the static analysis of all the steel pieces. And then at the end, a lot of craftsmanship as well to build it, to make it real on site, and section it of the lamellas. And to understand what it means to get these lamellas milled out of a horizontal board is you have really to unroll it out of a 3D model, and not only the lamella, you have to unroll each hole and each cutout and each cut at the end and the side lines as well. So you need to unwrap everything in a horizontal way and to cut it in a 3D axis machine. And yeah, in the top view looks like that, a bit easier, but yeah, it's challenging. And you have 25 layers, and each of the layers is different. Then you have to do the fabrication data for the milling process. As well, the nesting is very important to avoid a lot of cut off from the boards. So the main boards from Stora Enso They have a certain length and a certain dimension, and we need to pack all the lamellas into these boundaries. Loading order, also quite an important topic, otherwise we won't be able to install it on site if it's not in the right order. That has also worked out as well for the dome, pretty proper from Stora Enso. And then some facts and figures. As you can see, a couple of lamellas and a couple of meters lamellas and a lot of shear dowels as well, and also this cross connection dowels. Yeah, by the way, I need some organization, and I'm not sure, the pictures are not really well. I just got it through WhatsApp from the construction site, but I just wanted to show some of the current pictures, how it looks on site. So this one is basically the first layer, which was pre-glued and had also all those connections implemented, and then the following layers up to the current stage where we are now. Yeah, that's what it is. Thank you very much. I'd like to stay with this last picture if I can.
Absolutely. That's it. That's what it is. I guess for me, I'm more or less blown away. You are pushing the wood construction to the utmost limits, according to my opinion at least. And of course, I also wonder, how did this all start? Was it that Shigeru Ban came and knocked at your door and said, we have a quite difficult projects here. Could you help us? How did it start with this free-form construction?
Yeah, it was like the first project we have done in this free-form timber structure was the golf clubhouse for South Korea in Yeoju. It's about 1 hour from Seoul, and when Herman, by the way, was contacted by Shigeru Ban and was asked if this would be possible, and Herman is also a person who rarely says no. He always says that works somehow. we can do it, and yeah, then it has started a very important phase of collaboration and figuring out how we could. We even don't had a machine to mill those pieces. We haven't had software to get this blanks handled somewhere in 3D model, but we had a lot of experience in timber construction, and we had a lot of trust in that it would work somehow. And what we also had is a very good team of partners, such as the ones from SJB. Herman Blumer was on site. We had also the machine builder we had on site. We had Fabian Joiro from Design to Production on board. And there was a certain point when Katrina was deciding, let's do a meeting and we need to do a decision. And everyone was sitting at this table, and she was saying, do you feel that we should do that? If not, you should stand up and go out. Yeah, and no one was obviously went out, and that was the start of freeform timber construction. It was a lot of trust in our skills, and then we did it. And I was basically part of this first project. Was in 2007, and I have been able to do first programming the data and to handling the geometries. And I was several nights standing in front of this machine, and when everything was produced, by having one stop of 4 hours at Christmas evening and 5 hours of stop at New Year's Eve. We finished in mid of January somewhere, and then was the question, yeah, do you want to help with the installation, because we need some stuff on site. I felt like, yeah, this must be done. And that's always why I really like to tell this story. And I was working after this 10 years in the general contractor department, but I every time know I need to come back to this freeform stuff, because this is something what is really interesting. And yes, that's the start of freeform.
That's how it started. So it was Shigeru Ban
It was Shigeru Ban, yeah.
that knocked on your door, so to speak.
Yeah.
And I also think that this is a way of showing how you can develop the traditional craftsmanship into a new era using very high-end technology. And you have touched it, but of course you have a very interesting design team for your in your own company. Could you say something about how is that design team? What kind of
Background.
Background, knowledge, experience. What is your own background? Not your architect or engineer?
No, my background is, by the way, a carpenter. I have started my first apprenticeship after primary and secondary school. And it was just a way of exploring more and more and educate more and more. It's basically the most of us have started as a carpenter. Yeah, and we learned a lot about geometries, but we also learned that we as carpenters, we always think in a triangle or in a flat or in a straight way. And that was the point when we had. We have a lot of architects as well in our company, because they are really keen on handling those geometries and also the data. And we have also programmers and as well the machine drivers. They are, really not just only one. They need to do some special stuff, and they also need this kind of experience to try something out what never has been before. And but we are very mixed, and to combine this carpentry stuff with the very let's say sometimes nerdy stuff with geometries and scripting and everything, that's a challenge every time as well for each project. So you can imagine each project is new and no one has done this before, and they always kind of, what should I do? What's the next step? But even every time when the first piece is on the machine, everyone is kind of happy that it works somehow, and then it works. From this point, it always flows smoothly. And when then the installation is also good, then everyone is happy.
I can imagine, really. And you talked about different parametric design tools as Rhino and Grasshopper and so on, and you show pictures on quite advanced finite element methods calculations. Are you doing that stuff as well, or
no, I'm not.
then
no, it's
someone else?
Someone else needs to do that.
Because that kind of calculations, it reminds me rather on airspace design. Then
so what we focus
buildings.
on is for sure. Also, Daniel from our sales team, we are focused on the money calculation for sure. But all the geometry stuff we can handle. We can work out kind of a bill of quantity. But it's definitely not our stuff. We have to find out how can we get this price for a project like that. And this is the big challenge we always have. And it's getting better with the mock-ups, because you learn a lot about these mock-ups.
Absolutely.
And if you don't have this one, I think I would never even be able to calculate something. Because you learn all these processes in the mock-up.
I really think that we need to work much more with this kind of mock-ups, models, perhaps before we do these advanced calculations. You do that, the mock-ups, and you get a feeling that this will work, and then you need someone else to calculate it to show that what you feel is really the way it works. That's how you work.
And it's also the feeling out of our production when we do a mock-up.
Yeah.
They are just first part of the team, and then they know, okay, once maybe we need to build it, how could that work out? This mock-up is crucial was also for this project.
Yeah. And talking about this project, there are a lot of challenges, I can imagine. It's not hard to imagine. But if I ask you, you must mention one challenge that was very, very, when you perhaps thought, could this be done at all? Did that moment occur?
Yeah, I think it was basically a topic of communication, and it's even not easy for us as carpenters to understand what that means, or as carpenter background, what that means to unroll everything, to do these doubles, unwrapping everything, and fix it afterwards in a curved shape together again. You cannot describe it. You can also not measure it. It's in a 3D. You could scan it with a 3D scanner, but it's almost not until you see it at the end in a final shape. Until then, you can almost not imagine what it means to get it to this place. And this communication is also towards the client, or to the architects and to the engineer. It's even a bit better, but it's always about this communication, and you don't know when can we know what. You just feel like, okay, somehow in this way it could work, and then you try it out, and after the mock-up you have once to say, yeah, it costs maybe something. Yeah, but it's all about the communication.
Yeah, it's
as
all about
usual.
Communication. Absolutely. I'm also, I think I'm also inspired that you catch up what is already done way back, like Guberman, and also getting inspired of what is already done. I also used to refer to that story about the bridge. Do you think it's true?
I think it's true.
Okay.
But
then it's true.
Yeah, I think it's true. So it's kind of the experience of let's say the proud as well of the carpenters. They always want to bring up a bit the show on site, isn't it? We are quite fast. That's always like we always are a bit joking internally about clients and general contractors which are concerned in the contractual phase about the deadlines, and because there was no project so far when we were too late because of us.
No, and tonight
it's basically most time it's something in the basement, and as well this I would also mention the interface between timber structure and the concrete, the basement. This is a absolutely crucial thing, and you have to combine the timber engineering we are responsible for with the engineering of the local engineer. This collaboration is also pretty crucial.
And talking about precision, timeline, I think tonight you will have a party. What did you say it called? Dachrichtfest?
Aufrichtfest, genau.
Talk-Dogs-Fest.
Yeah.
And many of you from Blumer Lehmann will be in Stockholm.
Yes.
And I think that when you put out the timeline for this work, which date did you set out?
We said that it will be finished until Christmas,
Yes.
and it is obviously. We did a request to the client if it would be able that we can put our material and our tools together in January. But basically, it will be finished until end of year or before Christmas.
Yeah. Very impressive. And the tolerance for this entire building, I mean, it's about 150 meters long.
No, it's 50 something to 25 meters.
Okay.
Yeah.
And what kind of tolerance do we have in total?
We will see.
We will see. See what happens.
No, it's also this kind of pre-tensioning. So the columns are pre-tensioned into the basement. So we have 2 steel cables which are bringing these loads into the basement by pre-stressing, and this is also a bit high engineered, so to say. But we had no chance to get in another way these forces down to the basement.
Thank you very, very much, and enjoy tonight when you celebrate the roof, so to speak. And we give Martin and Blumer Lehmann a warm hand.
Thank you very much for your time. I just can add, build your future in timber.
Yes.